Advantages of chain drive, as no slip takes place during the chain drive, hence perfect velocity is obtained. Since the chain are made of metal, therefore they occupy less space in width less than the belt or rope drive. The chain drives may be used when distance between the shaft is less. The chain drive gives more transmission efficiency up to 98%. The chain drive gives less load on the shaft. The chain drive has the ability to transmit motion to several shafts by one chain only. Disadvantages: the production cost of chain is relatively high. The chain drive needs accurate mounting and careful maintenance. The chain drive has velocity fluctuation, especially when unduly stretched. Pitch of the chain. It is the distance between the hinge center of the link and the corresponding hinge center of the adjacent as shown. P-circle diameter of the chain sprocket. It is the diameter of the circle and which hinge centers of the chain lie. When the chain is wrapped around the sprocket as shown, the points A, B, C, D, hinge center of the chain and the circles drawn through these centers is called pitch circle. Relation between pitch and pitch circle diameter. So D is the diameter of the pitch circle and T is the number of teeth on the sprocket. So D is equal to P cosecant theta 180 degree by T. Classification of chains: hosting and hauling or crane chains. Conveyor or tractive chains, detachable or hook joint type chain, then closed joint type chain, then power transmitting or driving chain. Friction clutches. A friction clutch has its principal application in the transmission of power of shafts and machines which must be started and stopped frequently. The contact surfaces should develop a frictional force that may pick up and hold the load with reasonably low pressure between the contact surfaces. The heat of friction should be rapidly dissipated and the tendency to grab should be at minimum. The surface should be backed by material stiff enough to ensure a reasonably uniform distribution of pressure. Types. The friction clutches of the following types are important from the subject point of view: disc or plate clutch, single disc or multi disc clutch, cone clutch, and centrifugal clutch. This is a schematical diagram of single disc or plate clutch. So T is the torque transmitted by the clutch. So P intensity of axial pressure with which contact surfaces are held together, R1 and R2. External and internal radii of the friction force, and mu is equal to coefficient of friction. Consider an elementary ring of radius R and thickness dr as shown. We know that area of contact surface of the friction force is equal to 2 pi r dr. Normal and axial forces of the ring. So del W is equal to pressure into area is equal to P into 2 pi r dr. And the frictional force on the ring acting tangentially at radius r. So F suffix r is equal to mu into del W is equal to mu into rho into 2 pi r dr. Frictional torque acting on the ring. So T is equal to Fp into R. So mu rho into 2 pi r dr into R. So 2 pi mu into rho 2 dt. Considering uniform pressure, friction in journal bearing or friction circle. A journal bearing forms a turning pier. Fixed outer element of the turning pier is called bearing, and that portion inner element, that is shaft, which fits into the bearing, is called journal. Journal is slightly less in diameter than the bearing in order to permit movement of journal in bearing. When the bearing is not lubricated or the journal is stationary, then there is a line contact between the two elements as shown. The load W on the journal under normal reaction, that is R equal to W of the bearing acts through the center. The reaction Rn acts vertically upward at the point. This point is known as seat or point of pressure. Now consider a shaft rotating inside the bearing in clockwise direction as shown. The lubricant between journal and the bearing forms a thin layer which gives rise to a greasy friction. Therefore, the reaction now does not act vertically upward but acts at another point of pressure B. This is due to the fact that when shaft rotates, a frictional force F is equal to mu Rn acts at the circumference of the shaft, which has a tendency to rotate the shaft in opposite direction of motion. This is shafts the point to point A, B. In order to rotation may be maintained, there must be couple rotating the shaft. So pi angle of rotating R, the resultant of F and R suffix n and Rn. Coefficient of friction between the journal and bearing. Say frictional torque Newton meter, radius of shaft in meters. For uniform motion, the resultant force acting on the shaft must be 0 and the resultant turning moment on the shaft must be 0, in other words. So R is equal to W, T is equal to W into Cc. So W into OB into sin phi. Since phi is very small, therefore substituting sin phi is equal to tan phi. So T is equal to WR, tan phi is equal to mu into WR. So mu is equal to tan phi. If the shaft rotates with angular velocity omega radian per second, the power wasted in friction. So P is equal to T into omega. So T into omega is equal to 2 pi n by 60 watts. There, where n is equal to speed of the shaft in RPM. Friction of pivot and collar bearing. The rotating shaft are frequently subjected to thrust. The bearing surfaces such as pivot and collar bearings are used to take this axial thrust of the rotating shaft, the propeller shaft of ship, the shafts of steam turbine and vertical machine. Shafts are example of shafts which carry axial thrust.